Okay, so I want to take a minute and review the notion of work, because you may or may not have encountered the actual definition per physics of work. So the mechanical work done by applying a force which we'll call F, to move an object some distance and because we're talking about a distance, we're actually going to, and a magnitude, because that's a distance in a direction, meaning along the vector D is, so work is equal to the force applied times the distance moved. And when we introduce vectors, what we see is we need to scale that by the magnitude. Well, actually, that's not true. It's just force times force. It's just the dot product of the two vectors. The work done is the dot product of the two vectors. That's all there is to it. So, for example, let's suppose that a cart is pulled 20 feet by applying a force of 30 pounds on a rope held at 30 degrees, and this will be relative to the surface along which the cart is rolling. And what I want to know is how much work is done. So I've got a cart, and I draw really complicated carts. And my cart is being pulled along by a rope, right? And now my cart moves along this vector 20 feet, and I apply a force of 30 pounds to that vector at an angle of 30 degrees. So my force vector, if I put it in component form, is 30 times the cosine of 30 degrees, comma 30 times the sine of 30 degrees. My distance vector is 20, 0. I don't really need to do that, because all I need is work is equal to force dot distance. And we remember that that is the product of the magnitudes. That would be magnitude of force times the magnitude of my distance multiplied by the cosine of the angle in between them, which would be 30 times 20 times the cosine of 30 degrees. Cosine of 30 degrees is root 3 over 2. So this turns out to be 30 times 20 is 600 times the square root of 3 over 2, which ends up being 300 square root 3, which if you do the multiplication, that's approximately 519.615. Now, work is in foot pounds. And because we move, because our force is in pounds and we multiply it by distance of feet, so it's foot pounds. Now, a slightly different question is, how much of the applied 30-pound force goes towards moving the car forward? Whoops. That, what I'm asking for, is actually the magnitude, so the component of my applied force onto my direction vector. And we talked about that a minute ago. That's this guy, right? I got extra stuff. Right? So that is F dot D divided by the magnitude of D. So F dot D, we have that. That is 519.615 divided by the distance traveled. And my example doesn't have that written out for me. So that's 25.98 pounds. So you can think of that as kind of the efficiency of your effort. You apply 30 pounds, a little less than 26 of that 30 pounds goes towards actually accomplishing your goal of moving your car. All right, that is all we have in this section. I hope this has been interesting for you, and I'll be back in a minute. Well, I'll be back in the next videos to talk about section 8.6.